Geosynthetic design. Geosynthetic in drainage system. Geosynthetic with adjusted lateral drainage (ALD) abilities in roadway system. Introduction. What is geosynthetic? Geosynthetic are synthetic products used to stabilize terrain. They are generally polymeric products used to solve civil engineering problems. There are 5 functions of the geosynthetics. First, separating. The geosynthetic space between the two dissimilar materials maintain the integrity and functionality of the two materials. Second, filtration. The geosynthetic allows liquid flow across its plane while retaining fine particles of its upstream side. Third, reinforcement. The geosynthetic develops tensile force intended to maintain or improve the stability of the soil geosynthetic composite. Fourth, stiffening. The geosynthetic develops tensile force intended to control the deformation in the soil geosynthetic composite. Fifth, drainage. The geosynthetic allows liquid or gas flow within the plane of its structure. Function of geosynthetic in roadway structure. Geosynthetic with adjusted lateral design (ALD). Geosynthetic with ALD capabilities is particularly promising for roadway applications, as these products allow lateral drainage under unsaturated soil conditions and can facilitate drainage even under conditions of reverse gradient. Advances in the development of geotextile with adjusted lateral drainage. Conventional geosynthetic drainage products can only transfer flow once the surrounding soil becomes saturated. It's because a capillary barrier will develop if the soil in contact with a conventional geotextile is unsaturated. Accidental lateral drainage (ALD) geotextile is also to conduct flow through small capillary tubes with developed merit suction that facilitated the drainage of water stored within an adjacent unsaturated soil mass. The main objective of ALD geotextile is to mobilize flow under unsaturated conditions. Accordingly, while conventional geotextile can only provide in-plane flow under saturated conditions, ALD geotextile can also provide in-plane flow under unsaturated conditions. This is possible because of the effect of the surface tension acting on particularly small grovels. The difference with or without geosynthetic in drainage system. Without geosynthetic material, moisture trapped under a pavement will exacerbate pavement distress by increasing pore pressure and softening the subgrade soil. Second, impact of the road. Performance of a moisture-induced decrease in modulus in both of the base and subgrade layers. With geosynthetic material, first, diverting moisture that may have reached the base layer through downward infiltration and overt crack. Second, minimize moisture in the underlying subgrade soil. The benefit of ALD in a number of roadway situations. First, chances lateral drainage of moisture migrating upwards from a high water table. First, a symmetric pavement section that incorporated an ALD geotextile in a high water table scenario. As illustrated in the figure, incorporating lateral drainage into the pavement section help carry excess water outside the structural pavement layers. Upwardly migrating moisture that has reached the ALD geotextile can be laterally diverted to the pavement shoulders. where it can leave the system as evaporation. Incorporating of lateral drainage into the roadway section minimizes the problem associated with moisture-related awakening of the pavement subgrade. Second, efficient lateral drainage of moisture migrating downward of the surface. First, the developing over time leading to downward migration of moisture. The figures show the use of ALD geosynthetics to reduce excess water that may have penetrated into the base and subbase materials through downward infiltration, as well as through accumulation due to a capillary barrier. Third, control of frost heave induces pavement damage. First, ice lands develop when water migrated from the water table due to capillary rise, leads to the elevation corresponding for the first step. When we use ALD geosynthetics, the ALD geosynthetics will promote two favorable situations. First, minimizing upward migration access the geosynthetics by developing capillary barriers, and second, provide lateral drainage as access moisture to the edge of the pavement. Both actions will reduce the availability of water that may reach the frost depth and will minimize pavement damage associated with frost heave and soil weakening. Fourth, control the pavement damage caused by expensive clay subgrade. Illustrated the effect of placing an ALD geosynthetic at the interface of the base layer and expensive clay subgrade. The geosynthetic is able to homogenize the distribution of water along its entire length. At the pavement edge, the ALD geosynthetic will facilitate migration of moisture under unsaturated conditions, resulting in the comparatively uniform moisture distribution across the width of the pavement structure. In the subgrade, the improved uniform moisture distribution minimize differential vertical movement in the pavement and thus mitigate the development of longitudinal cracking. Central lateral drainage in projects involving soil improvement. The use of ALD geosynthetics to provide or complement the lateral drainage needed in soil improvement projects involve preloading and surcharge of soft soil using prefabricated vertical drainage. The ALD geosynthetic was placed to provide the required lateral drainage, separation, and subgrade stabilization. A temporary field was added to surcharge extended to an elevation of 10 feet or TM above the proposed embankment finished grade. Conclusion: conventional geosynthetic and granular drainage systems are unable to convey flow from base and subgrade material under unsaturated conditions. Thus, the incorporation of working yet into woven geosynthetics has led to the development of ALD geosynthetics, which are capable of conveying moisture stored in these unsaturated pavement layers. The use of ALD geosynthetics has shown pavement benefits complementing those strictly related to the actual lateral drainage. This included multiple applications of geosynthetics in pavement, including separation, all 5 case theories, subgrade stabilization. The use of the LD geosynthetics often because of the addition application that offer has shown cost saving associated with the decreased in thickness of the base layer. Thank you.